we talked a little bit about astrology, which is not something that I necessarily believe in, right? In fact, I don't believe in it at all. It's not astronomy. Astrology, people will say, it's, people who believe in it, is based on scientific facts, and that is true, right? And that if you were born, and here's the sun, and here's the earth, okay, and let's say a baby is born here, whatever, if you draw a line between the sun and the earth, and you keep going out into space, it's going to hit some constellation out here, okay, and let's say that constellation is Sagittarius, which is what I am, right? So Sagittarius, I was born in December, so here this line through the sun means that the sun is in Sagittarius, and that is my zodiac sign. That's my sign. That's my horoscope, whatever. And what it means is, or what people think it means is that the stars, the minute that I was born, and all the heavenly bodies are pulling on my body, the gravity of those stars are pulling on my body when I was born, that it sets my personality, okay? And therefore Sagittariuses and Tauruses can't marry each other, or they can't be friends because I don't know, it's just silliness. But the idea is that the gravity of these planets that surround the Earth and the gravity of the stars are pulling on the baby in utero, and it's changing the personality of the baby. It's a lot of hooey. But so let's prove it. For example, let's don't even think about stars that are light years away. Let's think about the nearest planet here. Let's think about maybe Mars. How does Mars pull on that baby? Okay, so here the Earth is orbiting the Sun. I should have drawn that circle smaller. Sorry. The Earth is orbiting the Sun, and then Mars is orbiting the Sun. Forgive my drawings here. And so the baby's born on Earth. One of the questions that students had is, do we have to consider the radius of each planet when we have to do these calculations? And if we look at the equation sheet here, okay, so here is Earth's mass and Mars's mass, and there's Earth's mean radius, about 6 million meters, and Mars is about half that size, 3 or so million meters, and that's pretty big, but 10 to the 6 million. If we look at the distance between the planets and the sun, it's 10 to the 11 meters. So this is 5 orders of magnitude, almost 5 orders of magnitude. This distance between, the sun and the Earth, call that RE, that is about 1.5 times 10 to the 11 meters. And the distance between the sun and Mars is about 2.3 times 10 to the 11 meters. We'll call that RM. And those distances are huge compared to these little distances. In fact, if I were to draw this to scale, I wouldn't be able to use this pen because this dot is not 10,000 times smaller than that distance there. You wouldn't be able to see the dot. So it's not drawn to scale. So the idea, again, is I want to know what is the effect of Mars's mass acting on the baby who's born on Earth, okay? And we'll even make it be the closest possible distance here, all right? And so when Mars is here next to the Earth, this is called perihelion. And then when Mars travels to the opposite side, right, when the Earth and Mars are in opposition, okay, this is called conjunction and opposition, then this is aphelion. Okay. So this distance is small, and this distance is quite large, much, much larger. Okay, and if we remind ourselves of the equation, right, that r squared term is going to have a tremendous impact. All right, so let's do it. Let's figure out what is the force of gravity acting on the baby, okay, due to Mars. And let's say the baby, let's say the baby is, I don't know, 2 kilograms, something like that, okay? And we need to calculate what this radius is. I'll let you be thinking about that as I continue to talk about the problem. So here, this is going to be g times the mass of one object, the mass of the baby, times the mass of the big object, or the second object, the mass of Mars, divided by r squared. And again, this is r. It's the distance between their two centers. So what is r? R is going to be the radius, the orbital radius of Mars minus the orbital radius of Earth. You know, convince yourself that this distance minus this distance is that distance. All right. And so if we just type it in. So let's see here. The orbital distance of Mars is this guy here, 2.28. Again, we're doing scientific notation to the 11th minus 1.496. Scientific notation to the 11th. Okay, hit enter. And so R is 7.84 times 10 to the 10 meters. Okay, so forgive me for not writing this down. I'm just trying to be quick because I'm running out of time here. If I were to then type this into the calculator, I would have alpha g times the mass of Mars, right, which is, or mass of the baby, sorry, mass of the baby, which is 2 kilograms, times the mass of Mars, and so the mass of Mars is 6.42. Again, scientific notation to the 23rd, divided by our answer here, our radius. I'm just going to do second answer, and I want to square that. Don't forget to square it, and then boom. So I see that this is 1.4 or so times 10 to the minus 8 newtons. So if we consider the effect that the planet, a huge planet, and fairly close as far as astronomical distances are concerned, very close proximity to the baby when it's born, it is a much smaller force than the force of gravity between two people, right? And so the doctor, you know, delivering the baby, she is pulling on the baby with more force than the heavenly bodies are. That is something to consider when you read your horoscope. And listen, don't get me wrong, I love horoscopes. I think they're hilarious. I think they're fun. Just like I love Marvel hero movies, right? I know it's not real, but yet it's still fun to think about. But the problem is, of course, if you start to think that they're rooted in science, and therefore that they're to be believed, just because there's a nugget of science in astrology doesn't mean that that is to be believed. Certainly not by my physics students. And I'm sure that comment's going to get a lot of traction, perhaps on the interwebs. So bring it on.